In this video, let us explore more about the ER model. We are discussing about the extended ER features, specialization and generalization. So let us discuss about the specialization first. This specialization and generalization concept, it is similar to the superclass subclass relationship in the inheritance. Yeah, you already know what you mean by superclass and subclass, right? Superclass means the class which will be having some common properties. All the subclass of a superclass will be having some its own properties, right? Yeah, similarly, in this case also, specialization also, an entity set may include subgroupings of entities that are distinct in some way from other entities in the set. Okay, some of the entities will be having some distinct properties. So such entities will be grouped together. For instance, a subset of entities within an entity set may have some attributes that are not shared by all the entities in the entity set. Okay, so the ER model provides needs for representing these distinctive entity groupings, and the process of designating subgrouping within an entity set is called specialization. The process of designating subgrouping within an entity set is called specialization. Okay, so it is a top-down process. Top-down process. So this process maximizes the difference between the members of an entity by identifying the distinguishing characteristics. As we said, will be this specialization and generalization concept will be similar to the superclass subclass relationship. Okay, so just keep on that point in mind. The superclass and subclass, the subclass will be having some properties of the superclass, right? Similarly, here also in the case of specialization, it is a top-down process. We are starting from a general class, we are starting from a superclass, and we are identifying the subgroupings, we are identifying the subclasses which will be having its own characteristics. Okay, so the process of maximizing the differences between the members of an entity by identifying their own characteristics, that process can be called as specialization. Okay, let us consider an example. We are considering the entity called staff. Okay, if we apply the process of specialization on the staff entity, we attempt to identify the differences between the members of this entity, such as the members with distinctive attributes or relationships. Okay, so we are considering the entity called staff. Okay, while considering the staff, we are identifying the differences between the members of this entity. Okay, so by considering all the entities in the staff, we are identifying some group which will be having some properties in common. For example, from the staff will be the manager will be having its own properties. The secretary will be having its own distinctive attributes, right? So we are maximizing the differences between the members of the entity itself. Okay, so that means we are specializing from the top, from the superclass, we are identifying the subclasses. So the staff with the job roles of manager, sales personnel, and secretary have its own distinctive attributes, and therefore we identify this manager, sales personnel, and secretary as the subclasses of the specialized staff superclass. Okay. Another example, the entity set person may be further classified into employee, student. Each of these person types is described by a set of attributes that include all the attributes of entity set person plus some possibly additional attributes. Okay, so employee will be having all the characteristics of the entity set person plus its own some additional attributes. Right. So such process can be called as specialization. The specialization of a person allows us to distinguish among person according to whether they are employees or customers. Let us consider another example, vehicle. So vehicle, bus, car, or four-wheeler, two-wheeler, we can categorize based on different, we can classify it, right, based on different characteristics. We can identify some of the attributes that are common, right? So from the base class or from the super class, we are maximizing the differences between the entities, and we are forming a group. So that group can be called as subclass. So this process can be called as specialization. So this specialization is a top-down design process where we are finding out the subgroupings within an entity set that will be having its own distinctive properties. Okay, so this subgrouping, so the subclasses that will become the lower level entity sets, and the attributes of the subgroupings cannot be applied to the higher level entity set. For example, the staff or the student. The student is an subclass of the person, right? So the person is the superclass and staff or the student is a subclass. Okay, the attribute grade of a student cannot be applied in general to all the persons, right? So this lower level entity sets attributes cannot be applied to the higher level entity set. Okay, so this relationship can also be called as superclass subclass relationship. It is also called as easy relationship. Easy relationship. Also, we can say it as superclass subclass relationship. The specialized class are often called as the subclasses. So the person is a superclass, and we will be getting this specialized class as staff or the student. So the subclasses are the specialized classes. Okay, then how we are going to denote this specialization into our ER diagram by means of a triangle component labeled with ISA. In Chen's notation, we are depicting it by means of a triangle component. Inside the triangle component, we will be labeling that triangle component with the term is A. Okay, and whereas in cross foot notation, we are using a hollow arrowhead pointing from the subclass to the superclass. Okay, from the specialized entity to the super entity or the other main entity. Okay, so this is the method to represent the specialization feature in our ER diagram. An example of specifying this specialization in the ER diagram is shown in the figure. A hollow arrowhead pointing from the specialized class named as employee or student is pointing towards the person, right? So a hollow triangle head is pointing from the subclass to the superclass. Okay, we'll be having two types of specialization, overlapping specialization and disjoint specialization. Okay, overlapping means the entity may belong to multiple specialized entity sets. That is, when an entity occurrence may be a member of more than one subclass. The person may belong to either student and employee. Some people may belong to both. Some of the employees are student or some of the students are employee, right? So that means we'll be having an overlapping specialization. Okay, so we'll be having subclasses, specialized entity sets, and these specialized entity sets may occur in overlapped fashion. Okay, some people may appear in both these specialized classes. We are using two separate arrows are used for denoting this overlapping specialization. Okay, so in our example, the employee and student, they are overlapping specialized sets. So they are using two separate arrows pointing towards the superclass person. Okay. The second type of specialization is disjoint specialization. It's also called as exclusive specialization. It belongs to at most one specialized entity set. Okay, so this will be applicable to a superclass which will be having more than one subclasses. Okay, and if the subclasses are disjoint, then an entity occurrence can be a member of only one of the subclasses. That means an employee can be a member of either an instructor or a secretary. It cannot be a member of in both the specialized class. Okay, hope the point is clear. Let me give you another example. Student either belongs to the class MCA class or belong to the beta class. He cannot belong to in both the streams. Similarly, he can be either a graduate or he can be either a postgraduate. He cannot belong to both the class. Okay, all these are disjoint class. That means the entity occurrence can be a member of only one of the subclasses. That means there is no overlapping. And so, a single arrow is used pointing from a single arrow is used pointing from the specialized class to the superclass. So this disjoint class can also be called as exclusive class. Okay, so these are the two types of specialization. We can also call this as the constraints of specialization, that we will be discussing it on the later slides. Okay. Now let us focus on to the generalization concept. Generalization is a bottom-up design process. We are finding out the common things between the entities. We are combining a number of entity sets that share the same properties into a higher level entity set. So the employee, the student, they can be combined, and the common features among these entities will be identified, and they will be combined into a higher entity set named as person. So we are finding the process of minimizing the differences between the entities by identifying the common characteristics. So it is just the opposite of the specialization. We are generalizing to a higher level entity set. So it is the result of taking the union of two or more disjoint lower level entity sets to produce a higher level entity set. This specialization and generalization are simply inversions of each other. It's just a complement of each other, and they are represented in an ER diagram in the same way. Specialization is represented using an E-set. This diagram can also be called as E-set diagram, right? Since we are representing this specialization with the help of this E-set triangle. So this is generalization can also be represented using the same notation.
So we are considering two entity sets as an example, the instructor entity set and the secretary entity set. Okay, fine. So these two entity sets have some attributes in common, like the ID, the name, the salary field, etc. Okay, so we are finding out the common attributes among the entity sets. Okay, based on the commonality, we are generalizing into a higher level entity set. So this instructor and secretary, based on the common attributes, they are generalized into a higher level entity set named as employee. So employee will be having some attributes like identifier, name, salary, etc. Right. So this is an example for generalization. So we are starting from the bottom and moving towards the from the lower to the higher. So it is a bottom up approach. Okay. The generalization and the specialization both can be represented using this hollow headed arrow. Uh, this diagram specifies that it consists of a hierarchy of entity sets. The concept is similar to the single inheritance and multiple inheritance concept. The higher level entity sets can be called as superclass, and the lower level entity sets can be called as subclasses. Okay, and so this relationship can also be called as superclass subclass relationship. Here the person is the superclass and the employee and student are the subclasses. Okay. Now let us discuss about the constraints on specialization or generalization. So there are three constraints that may apply to a specialization or generalization. The first one is membership constraint. It determines which entities can be the members of the lower entity. The second one is disjoint constraints. It determines whether or not the entities may belong to more than one lower entity set. And the completeness constraints, it determines whether we are going to have a total participation or partial participation. Okay. Okay, now let us discuss about the first type of constraint, that is membership constraint. Membership constraint determines which entities can be the members of the lower entity. It determines which entities can be the members of the lower entity. So this membership can be defined either by the user or can be defined based on a condition. So based on that, we'll be having two types of membership constraints. The first one is condition defined membership constraint, and the second one is user defined membership constraint. Okay, in the case of condition defined membership constraint, the membership of each subclass is evaluated on the basis of whether or not an entity satisfies the particular condition on the value of some attribute of the superclass. That is, the membership will be based on whether the condition is satisfied or not. For example, we are considering the entity called as employee, which has an attribute called job type. Okay, and we can specify the condition of membership in a subclass by stating the condition as job type is equal to secretary. So this condition is a constraint specifying that exactly those entities of the employee entity whose attribute value for job type is secretary belong to the subclass. So based on whether the condition is satisfied or not, if the condition is satisfied, that particular entity will be assigned to the subclass. Okay, so the first type of membership constraint is condition defined, also called as predicate defined. So it will be based on whether the entity is satisfying the particular condition, also called as predicate. So whether it satisfies the particular condition. If it satisfies, it will belong to the subclass. Right, so that is the condition defined membership constraint. The second type is user defined. When we do not have any condition for determining the membership, then the subclass is called as user defined. Here the membership is specified individually for each entity by the user, not by any condition that may be evaluated automatically. Here we are not specifying any condition to evaluate automatically. Instead, the membership is specified individually for each entity by the user, and that's why it is called as user defined membership constraint. So this membership constraint determines which entities can be the members of the lower entity. Either it can be defined by the user, or it can be defined automatically or evaluated automatically based on a particular condition. Okay, that's about the membership constraints. So the second type of constraint is disjoint constraints. We already discussed about this disjoint and overlapping in the specialized while we are discussing about the specialization. Okay, the disjoint says that it requires that the entity belongs to at most one specialized entity set. That means the employee, we consider the scenario employee, the instructor and the manager. The employee cannot belong to both the categories. It can be either an instructor or it can either a manager. Employee cannot act in both the roles. So that is, it is disjoint. That is, it belongs to at most one specialized entity set. Okay, then the second type of constraint is overlapping. That is, it can occur, it is possible the same entity may be a member of more than one subclass. The person can be an employee, as the person can be a student, or the employee can be a student. That means we can have multiple subclass sets. Okay, the same entity may be a member of more than one subclass. So that is the overlapping. Okay, so if an entity from the superclass can occur in multiple subclass, then it is overlapped, otherwise disjoint. Okay. Then the third type of constraint is completeness constraint. It specifies whether or not an entity in the higher level entity set must belong to at least one of the lower entity sets within the generalization or specialization. So we'll be having two types of completeness constraint. One is total completeness constraint and the second one is partial or incomplete constraint. Okay, in the case of total constraint, total completeness constraint, each higher level entity must belong to a lower entity set. Each higher level entity must belong to a lower entity set. That is total. And in the case of partial or incomplete, some of the entities, some of the higher level entities may not belong to any lower entity set. Okay, that means the participation is partial. Okay, so this is the third type of constraint. It can be either total or partial. If it is total, every entity must belong to lower entity set. If it is partial, some may belong to, some may not belong to any lower entity set. That is incomplete, or it is also called as partial. Okay, that's about the three types of constraints on specialization or generalization.